Thanks everybody for joining. Hope everybody's enjoying their dev days here. We just heard I'm going to be presenting against the real-time CDC for FHIR resources. And this is going to be more so of a technical talk, and you can kind of do this for any other data store that you have or any other data outside of FHIR. So use that for your own extra knowledge. So who am I? What am I about? I'm just a software engineer at Roche. I work as a part of the horizontal. We have a data platform, data services. We have a whole health data store as an offering inside of Roche in itself. So I've been within that entire ecosystem. And as of recently, I've been currently like the lead of building out our Gen AI infra for sensitive personal data for production and clinical use. So that's where I'm currently based at and working in within Roche. You can see this Navify product suite. It's kind of the backbone of what we're using. So yeah, just going to go over kind of what we're trying to get out of this topic here. So we're just going to quickly go over what CDC is, some overview, some terminology if you are not familiar with it, some goals and outcomes that what we wanted to achieve within Roche's CDC perspective, our technology stack of choice, the architecture that we have, including actual message shape of data that seemed reasonable enough. Maybe you could potentially reuse it yourself. And then, yeah, just what we have achieved with production metrics and graphs that goes along with it for one of our instances, and some challenges and recommendations that I very much have came across and would like to share with everybody here. So this CDC project essentially kind of spawned whenever I first joined Roche 5 years ago. We needed an issue with it. So it's been out in production for 4.5 years now. And essentially what CDC actually does is some software design pattern used to determine and track the data that's changed. So essentially the delta between what has came in and what is actually different. So it's really powerful for our healthcare systems. We know for a fact inside of hospitals, right? If some type of monitoring and devices are hooked up to something, if you're kind of out of stray, your heartbeat is starting to go lower, your oxygen rate, things like that, it differs ever so slightly. Alarms and bells and whistles will go in. There's action that starts happening in our healthcare system. So this is essentially the event hooks and the streams of data that we can feed into using change data capture. So some of our use cases that we're really interested in is, again, these real-time data notifications. That's just an example of one. You can trigger all sorts of job workflows within the data that you capture in itself. So I had presented a topic around our RPM use case. So the same sort of situation of, hey, we have a detected issue, you're outside of your care plan specification. Let's come in here, alert the patient to kind of get onto a better life cycle, or also the practitioner as well. You can define all these different workflows, all these different use cases, but really it's that valuable of having these hooks and the real-time data notifications. And then also real-time data synchronization. So we have inside of our ingestion process, how do you handle out-of-order processing? Well, do you just wait until a patient is created whenever you see their conditions and body structures and observations, or do you just continue on? And that's where this business identifier resolution, you ingest it and wait until the main identifier that's associated to it comes in. You wait it, you have it in cache ready to go, it comes in, gets ingested, and then you finally come in and resolve it. That's the BIR use case that we have. As well as how do you do data governance? How do you do data privacy and the data access? So why not also hook in multi-tenant organizations? You know, you have all these different things hooked in. So now you can say, hey, I got a new patient, I got a new organization, I got for some tenant, let's hook into where all of this actual sort of data governance happens, and then update that. So now we have this extra metadata, this body layer that says, hey, this patient now belongs to this organization. You have actually access to that in real time. And then as well as, you know, let's say the data lake integration for data analytics, algorithm development, secondary use, and other just aggregation of metrics and things like that that you normally would have. So quickly, let's just kind of go through some pub/sub terminology. There's some big entities in here. So there's brokers, producers, consumers, and topics. So a broker is just an entity that stores and manages data. Producers and consumers produce and consume that data. Kind of makes sense. And then topics are essentially the logical channel for these messages. And not all brokers are the same. There's some brokers that's 1 to n number of topics, if you really want to think about it that way. For example, a queuing system, you could have just kind of one topic, just the data feed coming in, and then you have many consumers coming out. So just general terminology. And this is really where it's more interesting. Within a topic in a message stream, data feed are kind of appended at the end, so the head of the message stream. And within the body of the message of a topic, they're kind of called offsets. So it's the sequential position of the message in itself. And there is lag behind, which is essentially where you're at in the position as a consumer to where the top part of the producer is at. So we can see here, consumer A is actually lagging behind where the producer is reading, where consumer B is actually ready to go. It has no lag. It's reading within the same head of where the message is at. So some of the goals that we wanted to handle with our CDC is we wanted to handle 1 to n number of database transactions. We wanted to do essentially any type of singular resource change or n number resource changes like transaction bundles. There could be a full patient being imported from an organization with conditions, observations, everything else like that. And we wanted it to happen, again, near real time, so less than 1 second. And all the elbows, so scalable, portable, reliable, and then as much minimal resource footprint as we possibly can. And then for our consumers, we wanted just to have some type of shape of data that they can use and hook into. So what are our options? It's like, okay, we went through and we're like, we do the classic, create views, and for database for latest changes, well, that doesn't really go out too well because the read times increases as your load is on the database. You can create triggers on the database, right? And then that's not really too good because then you're reliant on your database schema. It's not really that portable. And we can actually bake the CDC logic within the service itself. So this is what we actually had until we started getting more load. And per request and response, the latency of that happens. And then there is no fallback mechanism. And fallback mechanism doesn't really exist until we essentially find how you can actually do this distributed. So the last thing we looked into is how do databases actually work and do replication themselves. And then we found out, oh, there's a transaction log output. And this thing called this replication slot, let's hook into that, see what that works out. And this is what we ultimately ended up with. And this is our architecture here. So you can see the box up here. There's ingestion and different flows from end users, practitioners, whatever the case is, clients, coming into our service. This could be REST or GraphQL. We have it both. Into our FHIR data store, which is over Postgres. And then Postgres itself has this buffer that reads to the transaction log and has replication slots. And we have a service that sits and only listens to that replication slot, this eventing service, and then takes all of the FHIR resources themselves and publishes them out into that well-formed format that we defined, or the raw resource into our data lake, right, with Parquet and Apache Iceberg. It seems to take the cake to do data analytics on top. So what we ended up with is finding this open source software, which was Debezium. Fantastic, open source by Red Hat. And it uses Apache Kafka underneath the hood. If you're not familiar with that, that's like the de facto standard of eventing and replication at the moment. So because it's using Kafka, there's tons of database choices, makes it the most portable thing we can possibly think of using the same kind of API. And then there's essentially different operating modes, so you can really choose which infrastructure you want. Do you want to do embedded, everything's all in within the service itself, or do you want to do full, which is dealing with Kafka clusters and sharding and all that other good stuff? And our service in itself is Java Spring Boot. The Spring Boot aspect is very minimal just for configuration and small health checks for liveliness and readiness, as well as using the Happy FHIR library and Resilience 4J just to make sure it's as robust as possible. And our infra is SNS and SQS and S3 for our data analytics aspect. So, so a little bit about Debezium. Again, here is a Postgres, and there's a Medium article. This is exactly what I used to kind of get started with back in the day. I think it was 2018 is whenever this article was written. So this image was actually taken from there. The Postgres transactions will read to a buffer that gets sent to the transaction log, and Debezium hooks into the replication slot and only reads from there. And then it sends it to Kafka Connect and then greater Kafka. And if you choose the embedded mode, it's all within the service itself. And essentially what you get is these operations. Is it create, is it update, or is it delete? A source is essentially which type of schema and table, if you have the public schema and in Postgres, and which table it came from. And then you have a before and after as well as the timestamp. So if it's an update, you get a before and after. If it's a create, you only get the after, and a delete, you only get a before. So, and what we ended up with is, because of our database in itself, we kind of wanted to describe some type of shape that all of our consumers can hook into and reuse. So you can see resource type, resource version is not R4 in this case. It's the actual FHIR version. If there's more updates, you can have 10, 11, whatever it is. Resource ID, the action that was happened, the organization, so facility, who modified the subjects, if it's an observation, what patient is it related to, and then the message version as we change the version itself. So, and essentially what this version gives us is policies that we can define over SNS, essentially doing the KSQL aspect to send it out to all the other consumer groups. So you can describe one-to-one SQS on top of the SNS from that shape of data. So quickly, just some metrics and graphs. So again, we've been running 4.5 years, had only one incident, the Tokyo of 2022 incident. 7 regions deployed, 80 to 100 supporting FHIR resources that we have within our data platform itself. What we found is 1 to 2 CPUs is pretty fine. 2 to 4 gigs of memory is fine. 4 database connections, 5 to 10 minutes of offset, and then sub 1 second for singular resource transactions, receives and publishes. So, and then we have some quick metrics over here. This is our US region, and you can see the number of patients that came in, got updated or created, and about 5 million essentially resources that exist within this one instance that we have. And you can imagine as well, it's not even capturing the number of resources that got updated and created or deleted. These are just only the ones up to what has been created and what exists at the moment. So you can look into the replication slot lag as well as the disk usage to identify exactly where you're at in the position of your lag in itself, like I mentioned prior. So you can look at the database itself for these metrics. And we kind of, you can say we may have overtuned our services with those specs. So our CPU is pretty much always idling at 10 to 15% of what we gave it. And our memory is, you know, way under a gig of memory. It's kind of just whatever Spring and Java overhead is. You can kind of see this over time since April. Okay, let's give our eyes a break. So here's some challenges that we found is Postgres essentially has a one-to-one mapping to the database buffer and replication slot. Not using, or if the service degrades the write-ahead log, the buffer essentially scales with the database size itself. So if you have media types and other things like that of the raw resource comes in, that thing can grow kind of quite large. So very much you need to check for that. So choosing the appropriate columns and tables that you want for the replication that you want to do is very much good. We had like a 60 times improvement in a re-architecture for how we did our data governance, just because of choosing the right columns and tables. So with one of our rewrites, yeah, whenever you actually come in and include this, you know, you might actually have to start your database and turn it off to enable it the first time to create the logical replication. The timing for handling, committing, offset, schema updates, ignoring tables, I very much recommend having separate environments. So if somebody comes in and breaks or deletes everything from a table, you kind of can understand that. And yeah, handling multiple transactions within the same thing. So if you handle a bundle transaction, it's not the same thing as just one single Debezium entry. You need to understand the transaction and get all the resources in kind of a thread safe way for that transaction. So recommendations, again, I would check to see per deployment. Our US and EU kind of data comes in at a consistent flow. We have some other regions that very much at midnight their time, all the ingestion kind of happens. So spikes are completely different per region. Understanding that and tuning your resources kind of for that is really good. I would say alerting, monitoring your service, including the replication slot as well as the service for degradation, building resilience for circuit breaker patterns once whenever you hit your rate limiting and other types of throttling, so you don't go out of memory and blow up. And then last thing, always have a disaster recovery and a fallback plan. Our one little incident wasn't our service, it was our infrastructure. So always have a fallback plan that you can come back to. So, and the last thing is we were on FHIR R4. I think FHIR R5 has this subscription topic. So the event shape that we created, there was nothing defined at the time. There was no R5, or it was in draft. Yeah. Okay. Okay. That's good to know. So R4B has this exact 2 resources in here. Kind of. Yeah, so we were using R4.1. And what we found is, okay, yes, events coming in is fine and all, but we found there's a lot more appetite on these things called clinical concepts, which essentially means it's, hey, I have now year 1 observation coming in. It has an update. Okay, cool. That's what else? Like, I need to know also the past 5 observations for this patient, as well as the condition that's associated, and maybe the device that it was being used. It's like, those are sorts of the things that we found that the subscription topic would allow us to do. And then, yeah, instead of just sending over to SNS and SQS, we're looking at, okay, a larger scale Kafka with topics or Kinesis or something like that to enable these kind of clinical concept workflows. So conclusion, I would say Debezium's great. I would highly recommend it. And then SNS and SQS essentially gives you the flexibility that KSQL does without all the infra and using Debezium in embedded mode. So, awesome.
Questions? Questions?
So if I understand it right, if there would be R5 already available, you wouldn't do the whole exercise the same way again?
I think we would still build the CDC service in itself, but our potential event shape and the clinical concept workflow that we're looking at, we would probably have a better understanding that it is in a FHIR-related manner. There was no FHIR descriptor that kind of stated that, so we kind of made something that worked for us.
Right, and then under the hood, you would have your CDC running.
Yeah, under the hood, it would still be CDC, everything the same architecture, but behind the scenes, we just use the resource that is subscription topic instead of an SNS to SQS subscription kind of aspect. Yeah. If I go back to the picture here, these filter policies would be the subscription topics, and where they kind of get provisioned out to would be based upon the subscription itself. So that's where it would fit at, are these R5 resources. Yeah.
Okay, thank you.
More questions? Here.
Thanks for your talk. 2 questions. Do you have exactly one guarantee, like from creation of the resource or update all the way? And the second question is that how easy it is to modify that filter? Let's say that there is another field that I want to add that will be sent to the subscribers.
Sure. Yeah. I would say the first question, yes, it is pretty easy to work with, right? You can always go back and update essentially these fields here. You do have in Debezium the ability to choose what kind of subscription analysis you want. So we chose a guaranteed one kind of message coming in. However, if your service disappears, you based upon your offset and your position, there's 2 kind of flows. One, it is where you commit. So we chose 5 to 10 minutes. So if your service kind of goes offline between them, you as the service knows you're read to, let's say consumer A is offset is at 9, but the database itself also has a recognition of you've been committed this far. So it can pick up either one kind of where you left off at. And then it's as easy as updating our code and doing a deployment of what we send to SNS. Like if we want to change our event shape, and then your filter policy is based upon that, right? It's just SNS has a metadata header, and if we need to add any other metadata onto that, it's just a matter of updating code just for that header itself. Yeah, we we actually have put the entire resource in there now. But yes, there is a 256 KB resource size. So there is one version that has the full resource, and then there's one version that has the metadata.
So each one of these is the whole resource?
Correct. Yeah.
And I was wondering about that.
It can be. Or it is the event shape that you saw. If it a version 2 that doesn't have the resource in it at all, because the resource could be too big. Yeah. Yep. Mm-hmm.
One more question you want? If not, we are dismissed. Another applause.